All right. This next example requires some thinking, so I hope you took some time to at least think about it, um, because this is just asking us to take a look at that example 2 and see if we can figure out a way to write a set of parametric equations so that the motion is the same circle, but let's try and make it so that the motion is going in the clockwise direction instead of the counterclockwise direction. All right, that's a little tricky. So let's draw what that looks like. Okay, let's just draw this out. What would that look like? Now we could assume that we're going to start at the same point. So we had a circle, right? However, you can draw a circle, and we're going to start at the same point that we did. So this would be t equals 0, and the point is 1 comma 0, right? Okay, so I can also create a little table as I go along here. I want t, and I want x and y values. So I'm going to work backwards. Instead of starting with the equations, coming from the tables in the graph, I'm going to work from the graph, get the table, and then we'll see if we can figure out an equation. Okay, so now we want this to go clockwise, right? So the next point down here, let's say this is t equals pi over 2. Okay, this is just easy to work with, right? So we'll make these same. We'll make the t values the same as before. We had 3 pi over 2 and 2 pi. Okay. All right. And okay, so at t equals 0, we want x to be 0 and x to be 1 and y to be 0. And then down here at t equals pi over 2, here this is the point 0 comma minus 1. Okay, so 0 and minus 1. And then we want to travel in the clockwise direction over here to this point is negative 1 comma 0, right? At t equals pi. Okay, so negative 1 comma 0. And then up here, this would be t equals 3 pi over 2. And we're up at a point, this one is 0 comma 1. So 0 comma 1. And then finally, at t equals 2 pi, we're back to 1 comma 0. Okay, now let's take a look at what that looks like. Let me just draw a graph over here of x versus t, right? So this is x, all right, and this is t, all right. So we start up here at 1. We go down to 0 and then minus 1, back up to 0 and then 1 again, all right? So that looks like a cosine function to me. So I am just going to say x is equal to cosine of t, right? Because here the period is 2 pi, so at 2 pi I'll be back up where I started again, and it all works out nicely. All right, let's take a look at the y function. Whoops. So this is going to be y versus t. All right, so in this case we're starting at 0, but we're going down to negative 1, back up to 0, up to 1, and then back down to 0. Okay, that looks like a sine function that's been flipped over. So to flip over the sine function, we're just going to do negative sine of t. And if you look at that, it'll work. It'll work. It'll be a beautiful clockwise curve starting at 1 comma 0. All right, so here's another challenge. We want to do the same thing, only now we want this this circle to be traced out in half the time. All right, so we want the same. We're gonna go back to example 2. We want the same sort of motion around the circle. So let me draw the circle. So we want the same motion that we had. We're going to start here at t equals 0. But now we want half the time. So this is going to be t. Oops, got distracted here. This is going to be t equals pi over 4. Okay, half the time. Over here, it's going to be half the time. So this would be t equals um, pi over 2, right? Pi over 2. And then down here, this will be t equals 3 pi over 4. And then over here, we'll come back. Instead of taking pi, 2 pi to go all the way around, we're going to go all the way around in pi units of time. All right, so again, I'm just going to try to like work backwards. So I have t's, and I have x and y. X and y. Okay. Now, my x and y values are essentially the same as what I had before, right? I'm going to start at 1, 0, 0, 1, right? Negative 1, 0, 0, negative 1, and 1, 0. But now I want this to be traced in half the time. Okay, so what I'm actually going to do, I know that the input, if I make time, I'm going to make another column for time, and I'm going to call this 2t, because if I double the time, I'll have the same input to the sine and cosine functions, because I'm guessing it's going to be another function in terms of sine and cosine. But now if I put in 0, pi over 4, pi over 2, 3 pi over 4, and then pi, and then I double it, I'm going to have the same values for the input to the trig functions that I had before, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so if I just double the input, let's see. So my x is going to be, cosine of 2t, right? Because if I put in half the amount, essentially what I'm doing is I'm taking my cosine function, right, and I'm making it a composition with 2t, right? So it takes half the input, right? It takes half the input to get the same output, okay? So my functions are going to be x equals 2 cosine t and y equals 2 sine of 2t. What did I just say? X equals cosine of 2t, y equals sine of 2t.